So now we're going to do our first example of doing regression using StatCrunch to get the output that we need. So here we're going to start with a very small data set, looking at 6 students and looking at test 2 scores based upon how students did on test 1. So our 2 variables here are test 1 score and test 2 score. You'll see I put my test 2 score here on the y-axis because that's what I want to predict, that's what I want to find out. And we're going to see if I can use test 1 score to explain a student's test 2 score. So here's my 6 data points that I need. So first I'm just going to enter those into StatCrunch. So here I'm just going to open a blank StatCrunch screen. I'll go ahead and put test 1 and test 2 as my column titles and just enter in my data points. So there's my 6 data points. Now first, to just get that scatter plot that we were just looking at, I'm going to choose Graph Scatterplot, choose which one was my X variable and which one was my Y variable. And then of course I could put a title on this as well. One extra thing that some students like is to put these horizontal and vertical lines because it kind of gives you that graph paper feel. So there's our plot that we were just looking at. Now we're also going to get the least squares regression line. The StatCrunch output for you is actually here on the next page that we're going to use, as well as these directions that I'm going through. So now I'm going to be following the line directions. So I have my data entered versus actually loading it, so I could load the data as well. We're then going to go to Stat, Regression, Simple Linear. Then we're going to again choose our X and our Y. And at this point, that's all I'm going to do because that's all we're going to talk about currently. And then I'll show you the extra things that I added here shortly. So here is our output. The main things here that we're going to focus on right now are the intercept and slope of this 20 and 0.8. There's a lot of other information here. This is all we're going to focus on right now, is getting that intercept and slope. So looking at our output here that I've just sort of copy and pasted over, the main thing we're going to focus on, as I just said right now, is this little box of the intercept and slope, because this is going to give me my value of B, and then the slope is going to give me my value of M to use for my equation. So when I write out my equation, again, it's going to be a y hat because it's a predicted value, not necessarily the actual value. My slope was 0.8, so that's going to be multiplied by x, plus my intercept, which was 20. So again, we'll never have to calculate those. We're going to use StatCrunch to get those values. What we're also going to do is interpret appropriately. So as I mentioned in the previous video, we will always interpret slope. So let's go ahead and first just understand how we're going to interpret that value. Here it's positive, which I'm not shocked by at all because I see this positive trend going on with my scores. Now the value actually then tells me how the scores change. So the positive tells me that as test 1 scores increased, so do test 2 scores. But the 0.8 is telling me by how much. So I'm always going to look at x increasing by 1. So a 1 point increase in the test 1 score is expected to result in test 2 score increasing, since it was a positive slope, by this 0.8 points. So if I go back up here and look at my picture, it's going by 5s, but that's not what slope goes by. It's going by 1s. So imagine that I have like my 71, 72, 73, 74, 75 all on here. So it's saying if I go over 1 block for X, our test 1 score, I'm going to go about 0.8 blocks for my test 2 score. Over 1, up 0.8. Over 1, up 0.8. Over 1, up 0.8. Over 1, up 0.8. So it's kind of telling me for each one of these little increases I go up, how much I'm going to go up for my test 2 score as well. Things when we're looking at this interpretation. We're always going to be talking about X increasing by 1. So notice I didn't have to choose that number. It's always going to be 1. Here it's 1 point because that's what the test scores are measured in. Test 2 scores are also measured in points, but this number comes from the value my slope actually is. Now for the intercept, we have to decide if we're going to interpret them. So last time I mentioned that there are 3 questions that we're going to look through. What we didn't talk about then yet was, what am I actually looking for in these answers? Because now that it makes a little bit more sense since we're actually working with a problem, I want all of these to be yes to interpret my intercept. If even one of these has an answer of no, I am not going to be able to interpret my intercept. So let's talk through all 3 questions. The first one is, does x equal 0 make sense? Well, here our x is test 1 score. So can I have a test 1 score equal to a 0? Is that possible? It's possible. Not a good score, but it's possible. My second question is, can y, here that would be our test 2 score, be approximately equal to our b, or our intercept? So can test 2 be close to our intercept, which is 20? So could you get a test 2 score of around 20? Yes, we can. Finally, our third question is if we have any data near x equals 0. Again, x is our test 1 score. So we're asking, do we have any data near a test 1 score equal to 0? Well, there's 2 different ways for us to see the answer to this question. We can look at the actual data, test 1 scores. They only range between 70 and 90. Also visually, where would a test 1 score of 0 be? Somewhere way off this screen, right? I don't have any test 1 scores near 0. So for that reason, I'm going to say no, and that tells me to not interpret the intercept. We will see an example where we actually do get to interpret it, so you can see what an interpretation of the intercept will look like. Next, we're asked to find the predicted value for test 2 if you scored an 82 on test 1, or if you scored an 75 on test 1. Now, when I read predicted value for test 2, that's asking me to find my y hat. Because test 2 is y, predicted value is y hat. So as you can see, I'm actually going to be using this equation that we had above. But when I see an 82 on test 1, that's going to tell me, well, X is 82. So I'm just going to plug in that 82 in for X and see what comes out. And when we do that, I would get an 85.6. So I would expect them to score an 85.6 if they got an 82 on test 1 and 85.6 on test 2. Now I'll say, well, what about if you had a 75 on test 1? Well, same equation, just a different value of X. So y hat here will just be 0.8 times 75 this time, plus that 20. Now StatCrunch will also do this math for us. So this is one of those extra options I mentioned we can add in our regression. So if I go back to where I created the regression equation before, put in my values of X and Y again, you'll notice here there is something that says prediction of Y. And it allows me to put in different X values. So I could put in my 82 and my 75. And so then if I just hit compute, I'm going to get the same output that I had before. But now if I scroll down a little bit, you're going to see this new data here where it has the values of X and the predicted values of Y. We have the same information here in our output. And so the main things I would be looking at here is, again, just those first two columns. That's telling me my value of X. If I plug in a 75 for X, I got 80 for my predicted value of Y, or my Y hat. If I plug in 82, I got an 85.6. So StatCrunch will also do that same math, but that math wasn't necessarily hard to do by hand here. Finally, another thing that StatCrunch will do for you, and I believe it does it here automatically, is it actually graphs your data for you and puts that line on your graph. And if I hover over it there, it shows me the actual equation of the line. It does have things flipped. You'll notice that it has b plus mx instead of the mx plus b. So do notice that it actually changes things around. But it's actually not smart enough to put that hat automatically on top of y for us. So it just writes it as an equation of a regular line instead of our stochastic line where we know it's a predicted value. You can also hover up on the points here to see what the actual values of X and Y are, so that you can look at that. However, another question we're being asked to do is to calculate the residual for a student who scored a 75 on test 1. Now if you recall, the residual was the last thing in the previous video. It's the observed minus the predicted, or Y minus Y hat. So what I actually then need is a Y and a Y hat. Well, Y hat I already found. If you got a 75 on test 1, I expected you to get an 80 on test 2. Now, we actually had a student who scored a 75 on test 1, and their actual test 2 score was an 82. So that's my value of Y. So then now if I want to calculate my residual, which is Y minus Y hat, we're going to take 82 minus our 80 and get a 2. But especially since residuals are new to us, I want to interpret this number to make sure we know what that means. So here it's positive, so that means the student scored higher than we predicted on the test by 2 points. So the student scored 2 points higher than predicted on test 2. So that's just what that number means for us. Now continuing this problem on to our next page here. Would it make sense to use this model to predict a test 2 score for a student who scored a 35 on the first test? And then, of course, we'll explain why or why not that would be okay or not. Now, first, when I'm saying this model, what exactly do I mean by this model? Well, this model we're talking about is this equation of the line that we found, this 0.8x plus 20. So in a sense, I'm really asking, could I plug a 35 in for x? Would that be reasonable to do? Well, so maybe your first gut instinct would be, well, you could score a 35 on the first test. Sure, let's plug it in and see what happens. Now, we don't want to plug anything, though, into that equation. Let's actually go back and look at our data here, and maybe even better, look at it here in StatCrunch. So here are my test 1 scores. Where is a test 1 score of a 35? Probably somewhere over about here. So would it make sense to assume that this same trend just keeps going and going and going and going on forever? Well, that would be hard to really assume because this model, this line that I put on here, was based upon these 6 points. So I kind of feel very comfortable with what's going on between 70 and 90, but very far outside of that, I'd probably be pretty uncomfortable with. So then how I would explain my answer here, I would really say no. Mainly because we don't have test 1 scores near a 35 in our data. I don't have test 1 scores near 35. So I really would feel uncomfortable in plugging that value in then. So then that really might then beg the question, well, what value would you feel okay in plugging into our equation? Well, definitely for sure, anything between 70 and 90 feels pretty good. But would you feel okay with me maybe extending the line a little bit? Like this would be the same idea of, using the last 20 years of data to predict what's going to happen the next few years. I probably would be okay with extending it a little bit, but trying to extend it too far would probably make me feel uncomfortable. So maybe, since we're kind of going by 5s, maybe I'd be willing to go down to 65 and feel okay, and maybe up to about 95 and feel okay. But again, how far are you willing to go is somewhat subjective. But I would feel pretty good about doing it for test 1 scores between a 65 and a 95. Which then actually brings up this fancy word. There's this fancy word, it's called extrapolation. The first thing I want you to know about extrapolation is when you hear people use this word, it's really kind of saying that we're doing a bad thing. So when someone extrapolates, they're predicting a y for a value of x that is not close to the range of the data where you had. Basically, that would be plugging in that 35, is what we call extrapolating. So it's plugging in values into this equation that basically you shouldn't, because you really don't know if that pattern continues to exist that far outside where you have data. It's extending that line very, very dramatically in either direction that we really do not want to do. And we'll be talking about that word again, but it's sort of nice to hear more than once. So hopefully after watching this video, what I want you to feel comfortable with, one is using StatCrunch to get both the scatterplot that you see here, as well as getting that intercept and slope from StatCrunch. So make sure you feel good about getting those things. Then, once you have that output in front of you, I want you to feel good about being able to interpret the slope and intercept. And notice that we don't always interpret the intercept. Then you can also find a predicted value that you could calculate and interpret a residual as well. And finally, that you would feel comfortable in making a decision on what numbers you should or should not plug into this equation. In the next video, we're doing another example practicing this. So if you want to see how comfortable you feel, you could always try that on your own before you watch the next video. If you're feeling uncomfortable, go ahead and watch the next video and make note of questions that you have as you're going through it. That way it'll be a great starting point for you to start a dialogue with me to ask those questions.